Hello, in this video I'll be working through Unit 2 homework problems 1 and 2. For number 1, we're given the graph of f of x and asked to sketch and label two secant lines, one on the interval from -3 to -1 and the other on the interval from 0 to 2. So let's begin by sketching the secant line on the interval from -3 to -1. Those are x-coordinates. So at an x-coordinate of -3, our y-coordinate is 0. Okay, so we have this point at -3, 0. I'm just going to jot that down. And at -1, the x-coordinate looks like it's a little bit less than 2.5. So let's go with 2.4. So -1, comma, 2.4. Now we want to sketch the secant line passing through those 2 points. So this is a secant line. And a secant line is any line that passes through 2 points. Next, we're going to sketch the secant line that passes through points on the interval 0 to 2. So at x equals 0, our y-coordinate is 2. So I have the point 0, 2. And at x equals 2, the y-coordinate looks like it's a little bit more than 1. Let's go with 1.2. 2, 1.2, and we want to sketch the secant line that passes through those 2 points. Part B, sketch and label the tangent line to the graph at x equals -3. So at -3, our tangent line is just going to touch that curve. It's going to stay on the outside of the curve and just touch it at that 1 point. So about right there. So that's the tangent line to the graph at x equals -3. And then we also want to sketch the tangent at x equals 0. At x equals 0, our tangent's going to be about right there. Part C, what's the approximate value of the average rate of change of f on the interval from -1 to 3? Well, to find that, we're going to use our average rate of change formula, which is f of b minus f of a divided by b minus a. So on the interval from -3 to -1, I wrote down the coordinates of those points. I would subtract my y-coordinates, so we'd have 2.4 minus 0 over -1 minus -3, which is 1.2. So the average rate of change is approximately 1.2 on the interval from -3 to -1. Now on the interval from 0 to 2, I want to use that same formula, f of b minus f of a over b minus a, but now I'm using the points 0, 2 and 2, 1.2. So f of b minus f of a would be 1.2 minus 2 over b minus a would be 2 minus 0. So I'm just subtracting my y-coordinates, then subtracting my x-coordinates and finding that ratio. And that's approximately -0.4. How are these values related to your work in Part A? Well, these are just the slopes of those secant lines. If you find the change in y over the change in x, you're finding the slope of the line containing those 2 points. So these values represent the slopes of the corresponding secant lines. Part D, what's the approximate value of the instantaneous rate of change of f when x is -3? For that, we're going to find the slope of our tangent line. So I'm looking at, that's the green line. I'm just looking at rise over run to approximate this. And from this first point, it looks like I can go up 3 and right 1, and I'll be back on my tangent line. So the instantaneous rate of change at x equals -3 is approximately 3. And then at x equals 0, that's the orange line that I drew. The slope there, well, if I start right here, it looks like I can go down 3 and then right 4, and I'm back on my tangent line. So -3 over 4. How are these values related to your work in B and C? Well, they're related to part B because these values are the slopes of the corresponding tangent lines. How are these values related to our answers from part C? Well, the answers from part C could be used to approximate the answers that we got in part D. We can see that it's not a very close approximation, but if we had drawn our secant lines using points closer to x equals -3 and x equals 0, then our secant line, the slope of the secant line would have been closer to the slope of the tangent line. Number 2, we want to use the limit definition of the derivative to find the value of f prime of a. So here f of x is equal to -x, and our a value is equal to 2. So we're trying to find f prime of 2. Well, f prime of 2, using the limit definition of the derivative, is going to be the limit as h approaches 0, f of 2 plus h minus f of 2 over h. So we need to find an expression for f of 2 plus h, and we need to evaluate f of 2. So I'm just going to do that as side work over here. So f of 2 plus h, that means in function f, use 2 plus h as the input. So replace the x's with 2 plus h. So it's just negative 2 plus h. And if we simplify that, we get -2 minus h. We're also going to need f of 2. So f of 2 means go to function f and make the input 2. So replace all the x's with 2, and that would just be -2. So let's go back to our limit. We have the limit as h approaches 0. F of 2 plus h is equal to -2 minus h. We've already figured that out. Minus f of 2, and f of 2 is equal to -2. All of that is over h. So we'll continue simplifying. We have the limit as h approaches 0. -2 minus h minus -2 is just -h over h. And that is the limit as h approaches 0 of -1. Now we can find this limit using substitution. However, there are no h's left to substitute into, so this limit is just equal to -1. So now we have f prime of 2 equals -1. And f prime of 2 represents the slope of the curve at x equals 2. And the slope of the curve is also the slope of the line tangent to the curve. Slope of the line tangent to f of x at x equals 2. So if we consider the graph of y equals -x, y equals -x is a line that passes through the origin, has a slope of -1. So here's 2, -2. So what is the slope of the line tangent to f at x equals 2? Or remember, we can also just think of that as the slope of the curve. So the slope of f of x at x equals 2. Well, what is the slope of f of x at x equals 2? Here's the point where x equals 2, and the slope equals -1. So that does match the answer that we got. We got that f prime of 2 equals -1, and f prime of 2 just means the slope of the curve at x equals 2. Part B, f of x equals x squared minus 3x. We want to find the derivative when a is 2. So we want to find f prime of 2. F prime of 2 is equal to the limit as h approaches 0, f of 2 plus h minus f of 2 over h. So again, just off to the side, I'm going to evaluate f of 2 plus h. And for that, I'm just going to function f and substituting 2 plus h in for the x. So I get 2 plus h squared minus 3 times 2 plus h. Let's go ahead and continue to simplify that. 2 plus h, that quantity squared, will be 4 plus 4h plus h squared. Now I'm going to distribute this negative 3, so then negative 6 minus 3h. So we have 4 minus 6, that's negative 2. We have a 4h minus 3h, that's just h. And then I have an h squared. And we'll rewrite that in standard form, h squared plus h minus 2. Then I'm also going to need f of 2. So for f of 2, we just substitute 2 in for x into our function f. And that is 2 squared minus 3 times 2, or 4 minus 6, or negative 2. Now let's go back to our limit. So we want the limit as h approaches 0. F of 2 plus h is h squared plus h minus 2. Minus f of 2 is negative 2. So all of that over h. And this is going to be the limit as h approaches 0 of h squared plus h. Then here we have minus 2, and if we distribute that, plus 2. So the minus 2 plus 2 is just 0 over h, which is the limit as h approaches 0. If we factor in h out of the top, we're left with h plus 1 over h. Those h's cancel out. So we have the limit as h approaches 0 of h plus 1. And we can evaluate this limit using substitution. If I substitute 0 in for h, I just get 1. Okay, so I have f prime of 2 equals 1. And that tells me the slope of the curve at x equals 2 is 1, or the slope of the line tangent to the curve at x equals 2 is 1. Okay, if we look at the graph of f of x, looks approximately like that. So at x equals 2, we're right here, and the line tangent to the curve at that point does have a slope of 1. So saying f prime of 2 equals 1 tells us the slope of the tangent line when x is 2 is 1. Or we can simply say the slope of the curve at x equals 2 is 1. Part C, f of x equals 1 over x, a equals 1. So we are trying to find f prime of 1. F prime of 1 equals the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. Okay, so we know that f of x equals 1 over x, and that means that f of 1 plus h equals 1 over 1 plus h, and f of 1 equals 1 over 1, or just 1. So now we have the parts that we need to come back here and find our limit. We want the limit as h approaches 0. F of 1 plus h is 1 over 1 plus h, minus f of 1 is 1, all of that over h. So here we have a complex fraction. If we try and find the limit now using substitution, we're going to get 0 over 0, which doesn't tell us anything about the limit. So we need to simplify this algebraically. I'm going to multiply the top and the bottom by 1 plus h. Okay, top and the bottom by 1 plus h. So this is going to be the limit as h approaches 0. When I distribute this on the top, I just get 1 minus the quantity 1 plus h. And then on the bottom, I have h times 1 plus h. Now we continue to simplify. So we have limit as h approaches 0, 1 minus h over h times 1 plus h. So 1 minus 1 is 0. Then I have negative h over h. So the negative h over h just leaves me with a negative 1 on top. So I have limit as h approaches 0, negative 1 over 1 plus h. And if we find this limit using substitution, we substitute 0 in for the h, we get negative 1. So that tells me that f prime of 1 equals negative 1. And remember, this gives us the slope of the curve, or I could say the slope of the line tangent to the curve at x equals 1. So the slope of the curve at x equals 1 is negative 1. So let's just check on the graph and see if that seems correct. So if we graph y equals 1 over x, we get this hyperbola, and we have a point here at 1, 1. If we draw the tangent line where x is equal to 1, the line tangent to the curve looks about like that. I may be off a little bit, but we can see that the slope does look like it's negative 1. So f prime of 1 equals negative 1. Now this is part D, f of x equals sine x, a equals pi over 2. So we want to find f prime of pi over 2. F prime of pi over 2 equals f of pi over 2 plus h minus f of pi over 2 all over h. Oh, I forgot my limit. It's the limit as h approaches 0 of f of pi over 2 plus h minus f of pi over 2 over h. So we know f of x equals sine x. We're going to need f of pi over 2 plus h. So that's going to be the sine of pi over 2 plus h. Now there is a trig identity that tells us that the sine of pi over 2 plus h is equal to the cosine of h. That's one of our cofunction identities. So we'll use that. And we also need f of pi over 2. F of pi over 2 is sine of pi over 2, and the sine of pi over 2 is 1. So let's go back and compute our limit. The limit as h approaches 0, f of pi over 2 plus h, so that's just cosine h, minus f of pi over 2, that's 1, over h. Now this is one of our special trig limits, the limit of cosine h minus 1 over h. Or if you remember it as, if we factor negative 1 out of the top, that's 1 minus cosine h over h. But the 1 minus cosine h over h part of this product, that limit is going to approach 0. So negative 1 times 0 is still 0. This limit is 0. So we have f prime of pi over 2 equals 0, which tells us the slope of the curve, or the slope of the line tangent to the curve, slope of the line tangent to f of x at x equals pi over 2 is 0. And if it has a slope of 0, then the tangent line must be horizontal. Horizontal lines have a slope of 0. So let's consider the graph. Our function is just sine x. Okay, so looks approximately like this on its first positive cycle, where this is pi over 2 is here. And if we find the slope of the curve at pi over 2, we're at this point right here. So our tangent line is indeed horizontal. The slope of that horizontal line is 0. So we have f prime of pi over 2 equals 0. Part E, f of x equals square root of x and a equals 1. So we want to find f prime of 1. F prime of 1 will be the limit as h approaches 0, f of 1 plus h minus f of 1 over h. So our f of x equals square root of x. F of 1 plus h is square root 1 plus h. And f of 1 is square root of 1, which is equal to 1. So let's go back and evaluate our limit. Limit as h approaches 0. F of 1 plus h is the square root of 1 plus h minus f of 1 is 1 over h. Now, if we evaluate this limit using substitution, we get 0 over 0, which tells us nothing about the limit. So we need to simplify this algebraically. I'm going to multiply top and bottom by the conjugate. So we're going to multiply our numerators. And I'm not going to simplify the denominator any because I'm hoping the h is going to cancel out. But the numerators, I'm going to FOIL that out. So we have limit as h approaches 0, square root of 1 plus h times square root of 1 plus h is 1 plus h. The outer product and the inner product cancel out, and that always happens when you multiply by the conjugate. And then last times last, negative 1 times 1 is negative 1. Over my denominator, which is h times square root of 1 plus h plus 1. 1 minus 1 is 0. And then h divided by h, it just leaves me with a 1. So we have the limit as h approaches 0 of 1 over the square root of 1 plus h plus 1. And we'll find that limit using substitution. I substitute 0 in for the h. I get 1 over the square root of 1 plus 1, or 1/2. So now we have f prime of 1 equals 1/2. And again, this is the slope of the curve when x equals 1, or the slope of the line tangent to f of x at x equals 1. The slope of the line tangent to f of x at x equals 1 is 1/2. So let's just check that on the graph, make sure that seems right. The graph of y equals square root of x is going to look approximately like that. We have a point at 1, 1. And if we draw a line tangent to the graph at that point, the slope of that tangent line is 1/2. And finally, part f. F of x equals 2 minus the absolute value of x minus 1. We want to find the derivative at a equals 1. So find f prime of 1. F prime of 1 will be the limit as h approaches 0, f of 1 plus h minus f of 1 over h. So we have f of x is 2 minus the absolute value of x minus 1. F of 1 plus h is 2 minus the absolute value of 1 plus h minus 1. If we simplify that, we get 2 minus the absolute value of h. And then f of 1 will be 2 minus the absolute value of 1 minus 1. And the absolute value of 0 is 0, so that's equal to 2. So our limit as h approaches 0 of f of 1 plus h, we simplified to just 2 minus absolute value of h, minus f of 1, which is 2, all over h. And here the 2 minus 2, that's 0. So that cancels out, leaving the limit as h approaches 0 of negative absolute value of h over h. Negative absolute value of h over h. If we think about this graphically, if h is positive, then this is just going to equal negative 1. Because if h is positive, we can drop the absolute value, and we have negative h over h, which is just negative 1. So if h is positive, then the function is just equal to negative 1. If h is negative, then we remove the absolute value by putting a negative in front. So we would have negative negative h over h, which is just going to equal positive 1. So if h is negative, then the function is equal to positive 1. So what's happening here, the limit as h approaches 0 is different from the left and the right. We've got the left-hand limit as h approaches 0 from the left-hand side, is equal to 1. And the right-hand limit, so limit as we approach 0 from the right-hand side, is negative 1. And since those are different values, this limit does not exist. And if this limit does not exist, then f prime of 1 does not exist. So f prime of 1 is equal to the limit as h approaches 0 of this thing that we're computing, but it does not exist. So our derivative does not exist. And that means this function that we started with is not differentiable when x is equal to 1. Okay, so for this one, f prime of 1, we would just say does not exist. If we graph our original function, two minus absolute value of x minus 1, our graph looks like this, and we were trying to find the derivative at 1. So we can hopefully see from the graph here, there is no way to draw a tangent line because of this corner point here. I mean, if the tangent line is supposed to just touch the graph at one spot, I mean, does it look like this? Does it look like this? Does it look like this? There is no way to draw a tangent line at x equals 1 for this particular graph. So the derivative does not exist when x is 1.